Hello students, in the last video so far we have discussed the free body diagram, and in that free body diagram how the normal reaction, tension and Newton's laws of motion are applied in the free body diagram. And in this free body diagram, in the last video, as I told that we have discussed some of the numericals, or we can say that some of the applications we have done, and we done that free body diagram case, and again I am repeating how we will solve the numericals in free body diagram. So a diagram showing all the forces in the all the forces on a body, and that body should be isolated from the system, and using the Newton's laws of motion, second law, we will find the equation of motion of that body, and from there we solve and we will get the acceleration, tension, normal reaction, what the parameters is asked, that we can find by using the free body diagram. So next is the some of the other free body diagrams we will discuss here by using this concept of free body diagram. Let us solve some others is that motion of bodies in contact. Here we will discuss about the motion of bodies in contact. It means, my point is here, the two bodies has a contact between each other. So there is a physical contact between the two bodies, and we will apply this free body diagram, or that is also short form FBD. How we will find the acceleration, and what is the force acting on the body, and what is the force near the or at the point of contact between the two bodies, that we will discuss in this section. So in this part, so let us consider one of the example is that on a horizontal surface, let us consider two bodies of mass m1 and the other one is mass m2. So my point is, motion of bodies in contact means the bodies are contact like this, means there is a common surface between the two bodies. So this is the common surface, this is the point of contact or the region of contact between the two bodies. And let a force F is applied on the mass m1. A force F is applied on the mass m1. So we will discuss this type of numericals by using the concept of FBD. So here the force F is applied on the mass m1. So in this case, what happens in this part? Let us, as already you know that when we are discussing about FBD in the last class, in the last video we discussed that when we are using this FBD concept, what are the forces acting on each body, that we should find out. So if F is applied on the mass m1, so directly F is applied on m1, but this F is not applied to m2. But what is applied on m2? So when this F is applied on m1, m1 will push the mass m2, that is the action, because of F applied on m1. So if I will pull, or if I give a force to you and another body is in contact with you, so accordingly you will push the other body according to that. So a m1 will apply a force on m2, so let that is your, that force is let F, small f, that is the force on mass m2. Let this is the action. So then according to Newton's third law, to every action there is an equal and opposite reaction. So because of this small f, this m2 has applied a reaction F, equal and opposite. So that is the force at the contact, right? So this is the force of contact. This small f is the force of contact. So small f is the force of contact, and capital F is the force on the body of mass m1. Yes, that is the case. So now I will ask you, the question is, what is the acceleration of the bodies? So if the force is applied on this body, so let this is the acceleration. Suppose I will show, if the force is applied along this direction, so the acceleration will be along the direction of force. So this is the acceleration of the body. So the two bodies moves. To find the acceleration, I will use the concept that m1 and m2, so this is a system of bodies. This is a system. So let us consider this system is a one body. A system can consist of 2 or 3 or more number of bodies, but if I say that this m1 and m2, this total is a system of mass m1 plus m2, and a force F is applied, it produces an acceleration. So according to your Newton's second law, the acceleration of the system of bodies, that should be equal to A is equal to F by total mass. So the system mass is m1 plus m2. So this is the acceleration, and this acceleration is same for m1 and m2, because I have considered these two are a system, and this two is a, let us consider these two bodies are is a single body of mass m1 plus m2. So they both will move with the same acceleration. But now the question is, what is about this force of contact small m? That we have to find out. So to find this one F, let us find the free body, or let us apply the free body diagram. So in the free body diagram, the first step is sketch the total figure, and here next step is find what are the forces acting on each body, and that is the forces should be applied directly on the body. The forces applied directly on the bodies. So the FBD free body diagram for mass m1. Let us find for FBD for mass m1. So how to find this FBD for mass m1? So let us consider this is the mass m1, right? So or you can take a point mass also. So this is the mass, suppose m1. What are the forces are there? One force is obviously the applied force, like along this direction. So I can show this mass m1. This is the one of the force F along this direction. And the other forces are, as obviously the weight is vertically downward, m1g, weight is m1g. And if this m1, this is the surface, horizontal surface, if m1 has applied the weight m1g on the surface, so it has a reaction. That reaction is called as the normal reaction, which is always for this weight action, this is the reaction, and that should be normal to the surface. Which surface? Where the contact surface. So this is the contact surface. This is the contact surface. So this is the normal reaction R. Then in addition to that, another force is which one? On mass m1. The reaction force, the small f, that is the force of contact. F is the force on m1 by m2. So I can show this F along like this. This is the F. And the body has an acceleration in what direction? Along this direction A. This is the acceleration. Clear? So this is the free body diagram. Means here the mass is m1. We have considered this is the mass m1. Clear? Mass m1. Now, first point, in what direction the body is moving? The body is moving in the horizontal direction with this acceleration. If there is an acceleration along this direction, is there any acceleration vertically? There is no acceleration vertically, because the acceleration is horizontally, so the vertical component is 0. Because a vector is a horizontal vector. Suppose I will show a vector like this. What is its vertical component? So the acceleration is along this direction. So what is this vertical AB? That should be 0. The vertical component is 0 because A cos 90. So it has no acceleration vertically. It has vertically no acceleration. So vertically no acceleration means what? Vertically there are two forces and they are opposite, but no acceleration means these two combined effect is 0. So R is equal to, normal reaction is equal to, must be M1G. Clear? That is the first part. It has no role for the acceleration, but my point is to calculate this F. Now go for this F part. So because F is applied along right and small f is along left and the body has an acceleration along right. So the resultant is F must be larger. They are in the same direction, they are in the along the same line, opposite direction. So F minus small f. That gives you an acceleration, and acceleration is applied on mass m1. So the resultant force is m1a. So that is the concept from free body diagram. So this F is equal to F minus m1a. This is equal to F minus m1a. So that we got from the free body diagram. Another case is that, so this is the one part. So then go for the free body diagram for mass m2, FBD for mass m2. Here obviously this mass m2 is here. What are the forces acting on this mass m2? One force, this one along this direction, F gives an acceleration like this. So this F gives an acceleration because there is no direct force. This force is applied only m1. So this F is equal to m2a. F is equal to m2a. So to find this expression for F, I have got the expressions for small f in two cases. This one is easier for me using the formula. So this F is equal to, I can write m2. What is my A? A is equal to F divided by m1 plus m2. So this is the force at the contact point, right? So this is equal to, F is equal to m2 divided by m1 plus m2 into F. Clear? So with this, now we got the expression for, you also put that in this expression also, acceleration in this expression, then also you will get an expression, same expression for F, and you take this as a homework. So my force of contact F is equal to m2 divided by m1 plus m2 into applied force, external force F. Clear? This is the case where we can solve the numericals on free body diagram. In the same concept, if this force F is applied on mass m2, this force is applied on mass m2. So if this force is applied on mass m2, then by using the same concept, what is the force of contact and what is the acceleration? So if mass is applied, force is applied along this direction, obviously the acceleration will be along this direction. So the acceleration in this case A is equal to same F by m1 plus m2. But my point is, what about this F dash? Suppose this is the F dash. I will consider this as a F dash. So what is this F dash? F dash equal to, when this F, this external force is applied on m1, we got m2 by m1 plus m2. Do the same procedure and go for the free body diagram. You will get an expression F dash equal to, let me put directly, m1 by m1 plus m2 into F. Are you getting this thing? Right? So this is the expression. If you take in vector form, let me put all are in the same direction. So you can put this F, these are the in vector form, F dash. Clear? So this is the motion of bodies in contact. Then from here I will give you a homework that if there are three bodies are in contact, Three bodies are in contact. So take this as an homework. In the same question, if I say give you an expression like this, one is mass m1 in contact with mass m2 in contact with mass m3, and a force is applied on mass m1 and the acceleration is along this direction of applied force. Now we find this acceleration and the contact forces between m1 and m2 and m2 and m3, and that must be different. That must be different. If I show that, this take as an homework, F contact force, action reaction, in between them F dash, F dash, F dash, F dash. So you find F, F dash and this acceleration. And acceleration already you know that acceleration is equal to F by m1 plus m2 plus m3. But my point is to calculate this F contact forces and F dash, means contact force between m1 and m2 and m2 and m3. So take this as a homework. Okay. And if the question is asked like that, according to you can solve the numericals. A force F is given and is applied on the mass m1. Then if F is applied on the mass m1 and they are in contact, then you have to take m2 into F by m1 plus m2. If F is applied on the mass m1, then it will be m2. If mass is F is applied, capital F is applied or external force is applied on mass m1, then this is m2. If it is applied on m2, then this will be m1. Clear? So this is about the motion of bodies in contact. Okay. Now we will go for the next case is the motion of bodies in a horizontal surface. In horizontal surface. It means the two bodies are connected by a string. So if a string concept comes, then in the last video we already know that if a string is connected, the tension comes into play. Because in the string, along the string, we will get a tension. And what is the direction of tension? Already we know that. We have already solved some of the numericals in free body diagram. So now in this case, suppose my question is, let us consider the body of mass m1, another body of mass m2. They are connected by a string and moving along a horizontal surface with an acceleration a by the application of a force F. By the application of a force F. So this F is applied along this direction, it gives an acceleration on this, right? So now here, by using the free body diagram concept, we will find the expression for the acceleration, and the other factor is the string is connected, but in the last video, in the last question, they are in contact. There is no string connection, so there is no tension concept. But here the tension comes, and this motion is in horizontal. So the tension comes means, as you know, if the force is applied along this direction, so from mass m2, what will be the tension? Away from the mass m2. Then for action, if this is the action, then the reaction will be by mass m1 on m2, that will be the tension T. They are action and a reaction. Clear? For a body, how to show the tension? From that body, apply the tension away from that body. Now, for the acceleration of the system to find, as you know, if I consider this whole is a system, then A is equal to F by total mass is m1 plus m2. Means if you go for the next, in the last video as I already discussed, in the to make the things simpler, in every cases when you calculate the acceleration should be equal to the net force by the acceleration is equal to the net force divided by net mass. And this net force must be external force, no internal force. Here the tensions are the internal, F is the external. So obviously this F by m1 plus m2, if you write that in vector form, all are in the same direction. So A is equal to F by m1 plus m2. Got it? So this is the expression for acceleration. Now we will go for the expression for tension. So to get the tension, now we go for the free body diagram. So for mass m1, so for this mass m1, what is the tension? The tension is along this T. So for mass m1, let me draw the free body diagram. Let this is mass m1. The tension T is along this direction and it gives an acceleration like this. So the acceleration should be considered. So for mass m1, if I use the free body diagram, any other force is acting on mass m1, there is no other force, only the tension. So here we will say that P is equal to, that gives an acceleration. So that acceleration is a force, equivalent force is m1a. That is from free body diagram. Another expression for tension. So for mass m2, if I go for the free body diagram for mass m2, already you got the expression for acceleration and tension. But if you go for the mass m2, then obviously you will get the vector form. Then for mass m2, let me take this mass m2. Force along this direction, yes, F. And the other one is the tension, opposite, right? Because this is the tension on m1, right? This is the tension on m2. And this gives an acceleration along this. Now the body has an acceleration along the direction of external force, so F must be greater than this T. So I can put the magnitude for F minus T is equal to, give the resultant m2a. F minus T is equal to m2a. So here also you can get this T is equal to F minus m2a. And if you put this A is equal to F by m1 plus m2, then you will get the same expression, T is equal to m1 into A. Clear? So T is equal to m1 into A. Now in this expression, already you got the expression for acceleration and tension. If this is the case, same case, if it is a three body horizontal surface, there are three bodies are there, then you use the free body diagram. If there are three bodies are there like this, one mass m1 connected by a string to another body of mass m2 is connected by another body of mass m2, and the force is applied along this direction, and this gives the acceleration along this. Now you solve this by using the free body diagram, and their motion is in the horizontal surface. We are discussing about only horizontal surface. Clear? So how to find this acceleration and the tensions? So if the string changes between m1 and m2, there is one string, between m2 and m3 there is another string. If the string changes, then what happens? The tension also different. For different string, the tension will be different. So here one tension T1, action and reaction T2, m1 on m2 a tension because of this force, suppose T1 and this is T1 like this, action and reaction. In between m2 and m3, suppose T2 and T3, T2 and T2, action and reaction. Clear? From m2 the tension will be away from this one, from m3 T2. So this is the same string, so this is action reaction. Here is so m1 m2 action reaction T1 T2. Now we find the expressions for acceleration and these tensions in this case. So how to find this? Okay. So to get that one, let me solve one by one. For acceleration part, what I will do? Let us consider the net force by net mass. That is the simple method. Net force means this shape. These are the forces. Yes, the tensions are forces, but they are internal. We will not consider the internal forces. So A is equal to the net force by net mass. So what is the net force? The external force is F divided by net mass m1 plus m2 plus m3. So this is the expression for acceleration. If you write that in vector form, a is equal to f, both are in the same direction. So this is equal to m1 plus m2 plus m3. So I got the expression for acceleration. But the next important thing is find out these tensions T1 and T2. Find out the expressions for T1 and T2. So for this T2, it is not so much difficult. You can get this T2. Go for the mass M3, free body diagram. For M3, let me write here, for mass M3. Or first, let me go from this side for mass M1. For mass M1, what is the force acting on this mass M1? Only direct force is the force which acts directly on this one. Which one? This tension. This tension, not this one. This is the action and one is the reaction. So why I will take this T1? Then there is a confusion comes because the acceleration is along this direction. So if the acceleration is along this direction, there must be a force along this direction. So don't get confused. There are T1 and T2. So you can say that this is the tension on this mass M1 which gives the acceleration. So for mass M1, I will write T1. So let me draw the free body diagram. For mass M1, the tension is along this direction T1 which gives an acceleration along this direction. So I can write T1. T1 is equal to M1A. T1 is equal to M1A. Clear? Similarly, for mass M2, if you draw the free body diagram, for mass M2. So for mass M2, let me draw the free body diagram. This is M2. What are the forces are acting like here? Again, one tension. So this is the tension on M2. So M2 has a tension T1 by M1. So this is the direction of T1. Clear? This is the T1. Already this T1 is on M1. So this is the T1 on M2 along this direction. Again another one is the M2 T2. T2, this one. And it gives an acceleration A. Why I have considered this T2? Because this acceleration is along this direction, so this tension is the mass, is on the mass M2. So T2, T1, A. Now use the free body diagram. So free body diagram, by using the concept of free body diagram, the body has an acceleration along this direction of applied force. So T2 must be greater than T1. So I can write T2 minus T1 is equal to M2A. That is the for mass M2. And if you put that T1 is equal to M1A, you will get T2 minus M1A is equal to M2A. Or if you solve this one, T2 is equal to, this side if you take M1 plus M2 into A, or T2 is equal to M1 plus M2 divided by, A is equal to what? Divided by F by M1 plus M2 plus M3. Clear? So this is your T2. When you are calculating this T2, now you get an expression that, see, when you are calculating for T1, that is M1 into A, means this is the force on this body M1. So that is the concept you have to understand. This is the force on mass M1. It has no role to these things. It is ends here. Think like that. It ends here. So this direct force gives the acceleration. That's why you are getting T1 is equal to M1A. But T2 comes after M2. So after M2 means the mass will be M1 plus M2 into F by M1 plus M2 plus M3. Okay. So in that way you will solve the numericals on a three body system. Okay. Then we will go for the vertical case. The same cases, masses are connected but the bodies are taken in vertical position. Right. Let me solve for a vertical case. So now come to the case of in vertical direction. So let us consider the three bodies are placed like this in a vertical line. So this is your mass M1 connected by a string. to another mass M2 connected by a string to another mass M3, and the whole system is by a to a rigid support. You can take a rigid support like this, or the body is in a motion along this direction, so with an acceleration a. It is moving with an acceleration a. So now we will find what is the acceleration and the tensions in between M1, M2 and M2 and M3. Okay. So in this case, as you know, this has a tension that is T1 by M1. So if there is a rigid support, it will give another tension, action and reaction, that is T1 again opposite to this T1, equal and opposite, action reaction. So let me take that is a different one. Now the other factor is that this T1, M1 and M2 are connected by another string, so there is another tension comes into play, because the string changes, tension changes. So as the acceleration like this, so M2, from M2 let the tension is T2. Then from M3 the tension is T3, because this is another string. So this is T1, T2, T3. In this case, the body moves with an acceleration A upward. The body is moving with an acceleration A upward, connected by 3 strings. And suppose you think that you hold this end and you are pulling the whole system. You are pulling upward the whole system. Here we will find the acceleration and the factors like your tension T1, T2 and T3. So to get these expressions, as the weight factor comes here because there is a vertical motion. So vertical motion means the weight factor comes into play. So for mass M1, when you go for mass M1, draw the free body diagram. So for mass M1, the tension is this one, T1, and gives an acceleration this. Right? So I can write this as T1 is equal to M1A, because both are in the same direction, the tension and the acceleration upward. So T1 is equal to M1A. Now what is the acceleration of the whole system? The acceleration of the whole system is what? To calculate this acceleration of the whole system, if a force F is applied, along this direction, so this force is applied on the 3 masses M1 plus M2 plus M3, and this T1, T2, T3 are the internal forces, so the acceleration must be equal to the applied force by M1 plus M2 plus M3. That is your obvious thing. But next is you will find out this tension T1, M1 is there, but in addition to that, this M2 is also connected to M1 and M3 is also connected to M1. So while using this, according to this Newton's second law, if I use this one, T1 then minus, these all are connected, so consider this whole is a system, M1 plus M2 plus M3 into G, the whole weight, M1G, M2G, M3G all are in the same direction. So T1 minus of whole this one is equal to, the body has a motion in upward, so this is equal to M1 plus M2 plus M3 into the acceleration. So this is the case when there is no applied force. When there is no applied force, this is the case. So I can write like this, because of this tension T1, the body has an acceleration A upward, then I will write the equation like this. Clear? If there is no force is applied on vertical direction, I can write like this. Because this is not gives acceleration to M1. This acceleration is given to M1, M2, M3, and M1 is not only moving, M1 is connected to M2, M2 is connected to M3, so the whole system is moving like this. Right? So T1 minus the total weight of the system is equal to the total force acting in the upward direction. If this is your F, if this T1 or this is the F applied, then T1 minus this thing is equal to your expression. Okay. So here you will find this T1 is equal to, take this M1 plus M2 plus M3 this side and A plus G. Are you getting like this? If you take this M1, M2, M3 this side and take common, you will get the expression for T1 like this. Clear? So this is the expression for T1. Similarly, the tension T2. The tension T2. Now we will go for the tension T2. So to find the tension T2, in this case, it has an acceleration like this. So can I write like this? Let me leave this one because up to this we are taking. This is not the motion of M2, the weight M2G and also M3G. The total weight in downward direction is what? M2G plus M3G. Because T3 has cancelled here. Because they are in this whole system, as you know, X and reaction never cancel. But here T3 acts on M2 and T3 also acts on M3. So they are equal and opposite. When I consider this as a whole system, this T3 cancel out. So the next is the T2 is the force in upward direction. So the acceleration is in upward. So T2 minus M2 plus M3 into G, the total weight in downward. That gives you the resultant acceleration on M2 plus M3 into A. Yes. So this is the case. So T2 is equal to M2 plus M3 this side A plus G. That is the case for T2. Clear? Similarly, in the same way, find this T3. When you go for T3 minus which force? Only M3. When you are considering T3, this is not there. T3 minus M3G is equal to what? M3A. This is the expression. So T3 is equal to M3 into A plus G. This is the concepts of using the free body diagram. Okay. So when the whole system is in stationary, suppose in the same case the whole system is in stationary, then what the expression will be? If the whole system is in stationary, then we can say what? The whole system is stationary means in upward to the whole system tension T1, the total weight whole system is M1 plus M2 plus M3 into G. I can say the internal forces are like this. So consider this is a mass of M1 plus M2 plus M3. So if it a whole stationary means I can write this T1 should be equal to M1 plus M2 plus M3 into G. Got it? So this is the expression for the case for the system in a stationary. Okay, students. So we have discussed the bosons in a vertically and horizontally connected by a string and also in a contact. Okay. Fine, students. So these are the portions left in the first video of free body diagram that we have seen in the last video. So by using that, I think I have covered almost what is required in our council, the how to apply the free body diagram. We covered that thing, and if you get some extra, then you use the same concept of the what we are used in the two videos, that is the while solving the free body diagram case. Okay, student. And the other thing is that you go through the numericals given in the books or the materials supplied to you, and if you have any doubts, then you clarify it by asking. Thank you, students.